We are now looking at section 2.2. It's separable equations. So as I have mentioned before, this is something we did in a couple of examples using this method in chapter 1 and in section 1.3, I believe. So anyhow, we will do a little bit more complicated problem here. So in this case, the derivative will be often given as a function which can be separated into functions of two variables. So two functions being multiplied, one is of one variable and one is of the other variable. So let us see the examples now. So first example here is saying, show that the following differential equations are both separable. So if we can write the equations in this form, we call them separable differential equations. So at first sight, the equation doesn't look separable, but let us see what can do here. So if you notice here, dy and dx. So we want one function completely of y and one function completely of x. Remember, now we will treat them as differentials, so dy and dx, so we can separate them. So you can imagine that we can put cross the dx from here and put it over here, or we can do a completely new step. So we can say dy equals 2, by the way, can you see x can be factored out? So let's do that. X times 2 plus y over y square plus 1, and then dx. So you see now we have the function of x, just x. So we can keep x here and take this whole function of y on the other side. So it will come as, it will be reversed. So you will have y square plus 1 over y plus 2. And dy equals x dx. Well, we don't have to solve it, by the way. So, but anyhow, but you can see now we can, if we required, we can solve it. But here actually we showed it that this is a separable function, separable differential equation. Looking at the next. So I did this in class the other day, but here again. Okay, so this says ds by dt is equal to t times ln natural log of s to the 2t plus 8t square. So this is the one variable is s and the other is t. T is the independent and s is the dependent variable. So at the first sight, this doesn't look separable, but if you recall a property of the logarithm, which says that if you have a log to any base x, log of x to any base, but x is raised to some power, then the power can be put outside the log. So it is equal to m times log of x base a. So power comes in front. So we can do that to this power. So we get 2t, and there is another t already by outside there, so it becomes 2t square ln of s plus 8t squared, which can now be written as 2t squared, which we can factor out, and here we get ln of s plus 8. So we have a factor of t, function of t and a function of s. So separable. So in these parts, we just had to show that the equation is separable equation. So now we have question to solve the differential equation. Okay, so first one, so you can see already, I think it's easier to see it is separable. So we can write it y square dy is equal to x whole divided by x 1 plus x dx. So left side is easy to integrate, but the right side, if you recall, we have to do a u substitution. So what we do here for the right hand side, so let u equals 1 plus y, which means y will be equal to 1 plus x. Which implies x is equal to u minus 1. Okay, and dx is equal to du. So now we do the substitution for this on the right hand side. So our thing, x over square root of 1 plus x dx is equal to integral. So the top is now u minus 1 and the bottom is square root of u du. So how do we proceed now? If you recall, there is no quotient rule for entire derivatives or integrals. So what we do, we have to use our rule of exponents and basic algebra. Basic algebra means if you have a plus b divided by c, then you can write it as a over c plus b over c. So I have u minus 1 divided by square root of u. I can write it as u over square root of u minus 1 over square root of u. But u over square root of u is square root of u, and that is just 1 over minus square root of u. So I will write it like this. So this is equal to integral u over square root of u minus 1 over square root of u du. Okay, what do we do next? I have to simplify the exponents now. So I get square root of u minus 1. This remains as it is. But now we have to write the square root as a power, as a fraction. So the first term is u to the 1/2 minus second is u to the negative 1/2 du. Now integrate. So the first term gives us u to the 3/2. So 2 over 3 in the front, u to the 3/2 minus. So we add 1 to negative 1/2, so we get 1/2. So 2 u to the 1/2 plus c. So you can now plug back the value for u, which is x plus 1. So we get our answer for the right hand side. Okay. Now we look at the left hand side, which is giving us, putting them together, we get y cube over 3 is equal to 3/2 Usually it is expected that you give the answer in explicit form if possible. So in this case we can do that. So first thing we multiply by 3. So we get y cube equals 2 . sorry, this becomes 6 3c. And now we take the cube root. So we have y equals 2 times x plus 1 to the 3 halves minus 6 times x plus 1 to the 1 half plus 3c and whole thing cube root. So that is the answer. So in this case, you need to review your integration techniques. Okay, I will stop here and do the rest of the 2 examples in the next video.